This is page 10 of the fault tolerance notes, and this is section 3, reliable systems. And this is a precursor to talking about something called Byzantine fault tolerance. Using redundant computer systems is common in the aerospace industry, where failure is very expensive. So the idea is that you use redundant components, and the components can be processors. I'm going to talk about one extreme case where they use 9 different processors. Buses may be redundant. There are buses like the mil-spec 1553 bus, which has redundancy built into it. And sensors may also be redundant. And typically, you need a way, if you're duplicating measurements or values being transmitted or calculations, you need to settle on what's the correct value. So they combine outputs with typically a majority vote. Sometimes it could be a median vote, it could be a hardware averager or something like that, analog circuit. And so this can be internal or via hardware voters. When we talk about the Byzantine generals problem, we'll be looking at distributed computing systems where they cooperate together, the processors, to decide on what's the correct outcome. So just some historical examples was the Apollo rockets produced by NASA. There was a series of them, and they had one guidance computer, but it had triple modular redundant, or TMR, circuits, and it would use some kind of way to combine their outputs, like a majority vote. And this did add some fault tolerance, but the problem was that it was still one computer in one location, and so they moved away from that approach in later projects where they distributed computers in different parts of the spacecraft, such as with the space shuttle, so that if one got damaged in an accident, the others could carry on. In satellites, it's common to use dual systems, and so you have 2 processors that are online, and they are doing the calculations and generating output on their individual buses, but that's being monitored, and if their outputs differ, then it switches to another pair of processors that will take over using those buses for their output. So 2 pairs of identical processors doing the same thing, the same calculation, and if the main pair disagrees, it is taken offline, and the other pair take over doing the calculations. So it is a little more energy efficient in that you only have 2 running at a time, either the primary pair or the secondary pair. In the Boeing 777 jetliners, their flight computers consisted of 3 groups of 3 processors. A group consisted of the command processor, the monitor processor, and the standby processor if the command computer and the monitor processor don't agree. And each group used different processors. So one group used Motorola 68040. These were 32-bit processors, not pipelined, manufactured in the 80s. I think it was the 68040 that was in the first Macintosh computer. And another group used Intel 486s, or we usually just call them 486s, precursors to the Pentiums, and AMD 29030, so with similar capabilities. So different processors for each group, and they were running Ada code. So Ada is this standard programming language that was used by the American military for all its projects for a long time. They've moved away from that now, but they did use Ada. And the thing that's different is that this code was compiled by 3 different compilers for the different groups to eliminate that potential source of errors. The Airbus 380, which uses dual redundancy, plus it has a standby pair. So if the one pair goes offline, it goes to a second pair, and if that goes offline, then it can go to a standby pair. Okay, so now we can talk about software fault tolerance.